A fundamental part of the Bitcoin protocol is transactions. All the information stored in the chain is transaction data. So let's take a look at how they are made. The basic components of a Bitcoin transaction are inputs, outputs, and a transaction ID or TXID. Inputs refer to other transactions' outputs. Referencing an output in another transaction's input is how we spend Bitcoin. Each input of a transaction has three fields: a transaction ID and index number. These identify the output you're spending. There's also a field for a signature. The signature proves that you are authorized to spend the Bitcoin in that output. So what are transaction outputs? Outputs list who will be the new owner of the Bitcoin and give an amount. Each output of a transaction specifies a pub key and the amount of coins being locked up to that pub key. Once this transaction is confirmed or included in a block, the only way to spend those Bitcoin again is if you can make a signature that matches the lock in the pub key field on the output. Bitcoin transactions can have any number of outputs, but for our LARP game, we've limited the number of outputs to 4. Each output has an index number which start at 0. The index number helps us identify which output we're referring to when we go to spend them. Finally, every transaction has an ID, or TXID for short. In the LARP, we'll find this field at the top of the transaction form. Each transaction must have a unique identifier. This lets us identify outputs on a particular transaction without confusion. In the real Bitcoin protocol, the TXID is calculated from the data inside the transaction. We don't have an easy way to do this in the LARP game. Instead, each team will pick their own unique TXID when they make a new transaction. Part of verifying a transaction will be to make sure that the TXID is unique, so try to pick something that no one else will. Let's validate the first transaction we've received from the network. Every transaction that you get from the Bitcoin network must be validated before it is accepted by your node. Let's walk through validating your first network transaction. Since Bitcoin is a peer-to-peer network, it's possible that our peers may send us invalid transaction data. It's our job to make sure that all the data we accept from other nodes is valid. We'll use the transaction validation card to check that every transaction we receive is valid. The first item to check is the transaction ID. It must be a word, then a 2-digit number. The TXID on our first network transaction card is CAT72, which meets our criteria for a valid transaction ID. Next, we'll check if the inputs are valid. We need to check each input individually. There's space for up to 2 inputs on each transaction card. Our first network transaction has 1 input. The TXID is Eagle33 and the output index is 0. We need to find this output in either our mempool basket or our UTXO set basket. If we can't find it in either basket, we'll need to ask for the transaction from other nodes or discard this transaction. The Eagle33 transaction is in our UTXO set as it was our Genesis transaction. Let's find the output at index 0. The output at index 0 is locked up to a green lock and is worth 25 Bitcoin. There's only 1 input, so we'll write 25 on our transaction validation card. We should check that the input is signed to match the lock on the output we're spending. We'd expect there to be a green lock on the input. In this case, there's a mistake. The first network transaction is missing its signature. Just this once, let's help out and add the correct signature to the transaction to make it valid. Find a green lock and add it to the signature field on the input. Now we can check off this box on our transaction validation card. outputs and that they each have a lock on them. There are 3 outputs in our first network transaction card, and they each have a lock. We can check this off on our transaction validation card. Finally, we add up the value of each output. For this transaction, we find that there are 24 Bitcoins in the outputs. Let's write this onto the transaction validation card. The final checkbox asks if this amount, 24 Bitcoins, is less than the total amount of Bitcoin that was available in the inputs. We had 25 Bitcoin in the inputs and are spending 24 Bitcoin in the outputs. That means that we are okay. There are less output Bitcoin than input Bitcoins. Let's check this box off. This transaction is valid. Once a transaction has been validated, we can mark it as valid with our stamp and add it to the mempool. Transaction IDs are calculated from transaction data itself and uniquely identify that transaction. In the Bitcoin software, this is done using SHA-256, but we can't do this in real life very easily. Instead, nodes should pick a transaction ID themselves. If 2 nodes pick the same transaction ID, this will cause problems. It may be interesting to let the problems happen though, as a learning opportunity for participants to appreciate why not having duplicate TXIDs is necessary for the protocol to work. There have been 2 cases of duplicate transaction IDs in the protocol. This happens when coin-based transactions are identical. The protocol was changed so that this is no longer possible, but there are still 2 existing cases of duplicate transaction IDs. For more information, see BIP 30. Mempools are staging grounds for valid transactions that you've received over the network. It's the pool of transactions that we'll use to construct our next block. Once a transaction is added to the mempool, it's considered a candidate for a block. In the real world, mempools have a limit on the number of transactions that can fit into them. After that number gets hit, the mempool will start dumping out transactions. In the LARP, we likely won't hit this limit. Adding a transaction to the mempool should kick off a series of new network messages to nodes that you're connected to. We'll see this at work in the next phase when we start sending out information about transactions in our mempool. You may have noticed that in our first network transaction, we're missing 1 Bitcoin between the inputs and outputs. Where did this Bitcoin go? The answer is that this Bitcoin is available for miners to collect for themselves. It's a reward for them if they include your transaction into a block. Without this fee, a miner isn't incentivized to pick your transaction. Knowing how much a transaction is paying in fees may be useful information later in the LARP when we make our first block template. I'd suggest writing the amount of fees that a transaction pays on the back of a transaction so it's easy to see later. When you're writing your own Bitcoin transactions, you'll want to make sure that you pay a fee to the miner also. Okay, we're done validating our first network transaction and we've added it to the mempool. Let's figure out how to write our own transaction now. Every node should have 1 transaction in their mempool and 1 transaction in their UTXO set now. You should also all have an output that has Bitcoin locked up to the key in your Bitcoin wallet. Let's write our first Bitcoin transaction that spends the output that you have, either in the mempool or the UTXO set. Send 2 Bitcoin to the facilitator. The facilitator has a black lock color. Here's how I'd write a Bitcoin transaction to spend the blue locked output in the Genesis transaction. First, I'll need a blank transaction card. I need to identify the output I'm spending. It's on a transaction with the ID Eagle33, and it's at output index number 1. It has a value of 8 Bitcoin to spend. In my inputs, I'll write Eagle33 and output 1. I'll also add my signature, a blue key. For the outputs, I need to add one for the LARP facilitator worth 2 Bitcoin. I'll put down an amount of 2 and lock it up with a black lock. I need to decide how much Bitcoin I want to pay the miner. Currently, I'm paying the rest of the Bitcoin, or 6 Bitcoins, to the miner. I could pay a 6 Bitcoin fee to the miner, but that's a lot. I'd rather only pay them a 1 Bitcoin fee, so I need to give myself change. To do this, I'll add another output to my transaction, which pays 5 Bitcoin back to my Bitcoin wallet, which is a blue lock. Finally, I need to add a transaction ID to this transaction. I'll call my transaction Fiat88. That's all I need to do. My transaction is ready to be added to my mempool. I need to validate it first, add the approval stamp, and then put it into the mempool. This wraps up our phase on validating and creating Bitcoin transactions. We're ready to learn about how data moves between nodes.